Hello everyone, I'm Amir Hossein. Welcome to another training video about the RTTOV model. In this video, we talk about how to run RTTOV model to simulate a MODIS Terra sensor, MODIS Terra satellite sensor, using the WRF Chem model output for both atmospheric data and aerosol data. So if you have watched previous videos about the RTTOV model, you know that we use a special software called RTTOV Pi. This is a Python module. I have provided the link to this repository so you can easily clone it onto your local system. After cloning this repository, we go to the WRF data directory. And this is a special directory that you can extract atmospheric data or probably aerosol data from a WRF or WRF Chem model output, and then run the RTTOV model to simulate some satellite images. Let me open the name list here, and these directives, these variables are actually, you can set them just in the same way that we have discussed about it in the previous videos. This is the link to the RTTOV installation directory, and this is a coefficient file which is preset to, in this case, is set for EOS2 MODIS, which associates with MODIS Terra sensor. This is the path to the WRF output, in this case WRF Chem output, because we want to use the WRF Chem outputs for dust concentration. For aerosol, which in this case the aerosol would be dust concentration. Just let me show you the output, and I just want to show the dust concentration for this output. So if I find soil moisture, this is the domain. You can see that the domain is covering this is actually Mediterranean Sea, Red Sea, Persian Gulf, and Caspian Sea. So the domain is covering some parts of West Asia, and also it's there are some output here for dust concentration. This is the output for dust concentration over this domain, and you can see that the output is based on microgram per kilogram of dry air. So this atmosphere is actually affected by aerosol, and the aerosol in this case, we want to focus on dust concentration. You can of course you can simulate satellite images which are affected by which are based on atmosphere that is affected by any kind of aerosol, but in this case we want to focus on dust, on an atmosphere that is affected by dust. So I get back to the RTTOV Pi and our name list, and this is the simulation time, and you must be careful that the simulation must be included in your WRF output. So this is just a time slide within the WRF output, and these two lines, you don't need to change them. They are used for naming the output, the directory that which will be created after you run the application. And this is the important block, this WRF Chem dust profile block. And if you want to simulate the satellite image, which using data of an atmosphere that is affected by aerosols, or in which case dust concentration, you need to set this block. So first of all, you enable it in this variable, you set it true for this enable directive, and this is a special coefficient file which is for scattering parameters for the satellite sensor that we want to simulate it. And in our case, as we discussed, the satellite sensor is MODIS Terra. So both of them should actually refer to the same satellite sensor. In this case, both of them are referring to the MODIS Terra satellite. And this is the satellite information. The satellite name index is number 1, and if I go to the another tab, and if I open the satellite names here, you can see that number 1 is EOS Aqua. I think I mistakenly said MODIS Terra. Actually, it is MODIS Aqua. So we are going to simulate MODIS Aqua satellite sensor image. So and we have also a post-processing block here. For this time I disable it. I put false. I set false for this enabled directive, and I just want to extract variables, atmospheric data variables, and also aerosol data, which is dust, out of the WRF Chem model output. Here I save it and I run the code. One issue that came to my mind is that if you have not enabled special environments, which includes all the required Python modules, it will throw some errors. For example, in this case, I have not enabled the suitable Python environment or Conda environment, and it throws an error saying that the Python module netcdf4 is not available or is not installed. But in this shell, you can see that I'm running this code on a special environment, Conda environment, that all the required Python modules are installed. So I run it, Python run, and this directory has been created, and all the profile data files will be made for each grid point in the WRF Chem model output. So now you can see that we have a new directory, and inside the directory, if I show you, we have two kinds of files. The first file is atmospheric data for all the grid points within the WRF Chem output. So we have 3,844 grid points, and also the same number of files for another input data, which this input data is for aerosol, for the same number of files. Let me just open one of these aerosol files. I opened one of these aerosol files, and if you see that there are 3 columns here. These 3 columns are related to dust concentration. If you want to know more about the meaning of these aerosol species, you can study the document, the RTTOV model document. But in this case, since we have only dust concentration, we extracted the concentration of dust variables for each grid point. So you can see that the other species variables are actually 0. There is no value for other species. We are focused only for dust. Okay, now I have a directory, separate directory for profile data, and also I have a shell script that I can use to run RTTOV model for each variables, for each profile data within this directory. So inside the directory, as I showed you, we have 3,844 profile data. So if I run this newly generated shell script, if I run it, and you should set an argument for it, Fortran. The argument is a specification of the compiler, Fortran compiler, that you use to compile RTTOV model. If I run this shell script, it actually runs the RTTOV model and more than 3,800 times for each profile data which is extracted from the WRF Chem output and stored it in this directory. So I just run it. Depending on your system, it takes some time. It may take a few minutes, since it has to run the RTTOV model for the number of available grid points in your WRF Chem or WRF model. Actually, I have run it beforehand, so I have the outputs. I just stop it, and I have run it before. So this is in this new directory, we have 3,844. After the run process is finished, we have 3,844 output files, RTTOV output files, which is the result of the RTTOV model or result of the RTTOV model simulation for each grid point. So let's say if I open this result, I can see the calculated brightness temperature, and this can get what is the difference of this calculated brightness temperature from the previous RTTOV run, which we didn't use any dust concentration. The difference is that this calculated brightness temperature is simulated considering that the atmosphere is not a clear atmosphere. Atmosphere was not a clear sky atmosphere, and atmosphere was affected by aerosols. So this is different kind of RTTOV simulation or radiation transfer simulation. And some physical phenomena, let's say scattering and absorption, are included in this simulation. So let me get back to the parent directory. I open namelist again, and I just want to post processes. I set it to true, and in this case I skip the RGB plot RGB plot for brightness temperature, and I just want to plot some images for each calculated or simulated image. And here this post-processing, if you remember from our previous videos, this post-processing, it functions it is functioning for making netCDF data and also plot images of the same generated netCDF data. I save it and I run the code again. Plotting, it has actually it plotted each channels that we specified in the name list in different netcdf files. I go to the newly generated directory output post-processing. Okay, if I let me open the netcdf file. This is a netcdf file for the 3 channels that we specified in the name list. And here you can see that there is a difference in our in the plot or in the pattern of our output. You can see that it has a circular pattern, and here in the white area we don't have any value, and these white area are actually missing value. What was the reason of this phenomena? The reason was that if we go back to the name list, let me go back to the name list. In the name list, the location of the satellite, it was a user-defined satellite, location of the satellite, and the location was 33 and 55. 33 for the latitude and 55 for longitude. 33 is almost in the middle of our domain. 33 is almost in the middle of the domain, the middle latitude in this domain, but 55 is this region, is actually this region, so the satellite position is outside of the domain. And so if the satellite is outside of the domain, the grid points which are far from the satellite, I mean the grid points that are in the west region of the domain, they will have a very slanted zenith angle. Zenith angle is very important in calculating or simulating radiation transfer. If the zenith angle is higher than 75 degrees, or in some cases higher than 80 degrees, the RTTOV simulation cannot be possible. So for those grid points which are far from the satellite location, in this case in the west grid points, we have no RTTOV simulation, and so the output for these grid points are displayed as missing value. So yeah, this was a short video about how to run RTTOV model using a WRF Chem model output, extracting both atmospheric data and aerosol concentration, which in this case was about dust concentration, and so we could successfully run the RTTOV model to simulate MODIS AQUA images. One other thing that I forgot to show you was the plot. Also, you can have the plot of these plots are actually generated from the netcdf files. After the netcdf files are generated, these plots are also can also be generated from for each variable, and each variable in this case it has 3 different channels: red, green and blue. Red, green and blue.